motivation behind this project was to create an environment where probability can be understood intuitively. Probability exists everywhere in the world around us, and learning it at an early age can provide an advantage. We wanted to make the project accessible to a variety of ages for this reason, as well as reaching a larger demographic with the product. We also wanted to implement sound electrical engineering principles in both our design and construction phase. The principles applied for this project included the engineering design process, a Gantt chart scheduler to ensure we stayed on track, the use of C++ code flowcharting, and the use of top-down design based on those flowcharts, as well as circuit debugging and analysis during our design and construction phase. This project went through many different iterations throughout the course of our design phase. On the left is the first iteration of the design we generated during brainstorming, and on the right is the final iteration we designed. You can see there are many similarities between the designs, but each has its differences as well. For starters, both designs use a swivel top to rotate the cards to the position of each player, as well as a dispensing wheel to disperse the cards from the dispenser. They also have a solid base where the main electronics are displayed and contained, but they differ in the fact that the frame kit was utilized differently than we had assumed in our first iteration. The process we used for this project closely followed the engineering design process. We first began with brainstorming. Figure 3 shows some of our early brainstorming concepts for how we wanted to integrate both the frame kit and the swivel components. After brainstorming, we implemented a Gantt chart and created a schedule to keep us on track. We then, from our initial brainstorming, worked on the frame design, which we solidified before we began working on the code and electronic components, as we were not sure how we were going to integrate them into the frame until it was built. Once that was completed, the code was written for each subsystem of our electric system. The LCD screen and joystick were first programmed. To do this, Figure 4 shows the joystick testing, where each axis was wired into an LED to ensure that when you select with an axis, the output is working correctly. We then tested and implemented an LCD, coding that in and ensuring it would print Hello World. The final subsystem we worked on were the motors, first programming the stepper motor to ensure it was stepping in the correct directions, and then programming the DC motor to ensure it would spin quick enough to dispense the cards from our swivel top. Once each of our subsystems were functioning correctly, we began to tweak our final frame design in order to better incorporate these components and to allow for structural integrity as well as correct functionality. After this, we did the integration where we added all of our electric components into our frame. The way our product works is you first enter the number of players using the joystick and LCD. Similarly, the number of cards per player are also entered in this fashion. Once this has been selected, the stepper motor will turn to the first player, and the DC motor will deal the card. This process is repeated for each player times the number of cards per player. After the system is finished dealing, it will reset to its original position, allowing for the cards to be reshuffled, and the system resets, allowing for further use. The first issue we found while we were designing this product was the structural instability of the 40 frame kits. Many of the components we were using were quite heavy for their size, and the way our frame kit was designed in our initial iterations, it was not strong enough to secure and support these components. In order to address this issue, we redesigned the frame to be stronger with the use of triangular shaping, as well as utilizing hot glue, zip ties, and rubber bands to ensure the kit stays together and does not flex under the weight of our components. The next issue we encountered was insufficient power. Utilizing the 5-volt supply from the Arduino simply was not enough, as we were running so many different electrical components, including the joystick, LCD, stepper motor, and DC motor. We were unable to power all of these components from that singular port, So, using circuit analysis, we were able to reroute our power as well as an op-amp in order to supply more
네,
voltage.
교수님 여기까지 보고
네.
역시 작동 영상을 보고 싶네요.
네. 아마 이 정도.
On the right, you'll have a clip of the as a demonstration.
네, 잘 봤습니다. 네, 이제 질문 드리겠습니다.
네.
역시 이 같은 대학교 학생들인 거죠? 그러면.
네, 다 같은 대학교 학생입니다.
네. 이 프로젝트를 준비한 팀은 그러면 또 누구를 대상으로 이렇게 프로젝트를 진행했는지 궁금합니다.
이 프로젝트는 사실 기본적으로 확률을 가르쳐 줄 수 있는 프로덕트인데, 사실 카드 딜러라는 게 게임이기 때문에 거의 전 학년을 대상으로 사실은 사용할 수 있다고 생각을 하고 있습니다.
예. 이 카드 지금 나오고 있는 이런 카드가 실제로 한국에서 보면 한국의 현실에서는 조금 한국에서는 조금 어울리지 않는 그런 내용이어서 혹시 그 프로젝트 준비하는 팀에서 카드 딜러가 아닌 좀 다른 교육적 프로그램에도 좀 다양하게 적용시킬 수도 있을 것 같은데 뭐 그런 생각은 안 해봤나요, 혹시?
네, 카드가 이거는 이제 갬블링용 카드인데 다른 카드들도 사실 있거든요. 그 어린이들이 사용하는 카드들 중에서 이제 숫자가 정해진 카드가 숫자랑 그 패턴이 정해진 카드가 있다면은 그거를 사용해도 괜찮을 것 같습니다.
예. 일단 포디 프레임을 사용한 부분은 아마 모터를 올려놓는 그런 지지하는 그런 프레임 같아요. 마찬가지로 이 프레임을 좀 프레임이 조금 더 튼튼하게 제작될 수 있는 방법은 없었는지 그게 좀 궁금합니다.
네, 안 그래도 프레임이 이게 위에 카드가 맨이 올라가고 모터도 올라가다 보니까 좀 휘어서 좀 애를 먹은 걸로 알고 있는데, 그 자기들 나름대로는 이제 러버 밴드나 이렇게 집타이나 이런 걸 사용해서 했는데, 사실 조금 더 이렇게 촘촘하게 프레임을 만들었다면 좀 더 이렇게 견고하게 만들 수 있지 않을까 생각을 했었습니다.
예. 발표 잘 들었습니다. 역시 10번 팀에게도 프로젝트 준비하느라고 수고했다는 말을 전해주겠습니다.